Hello everybody, it's Andy here from A Media Games, and in today's video I'm going to be going over physics-based audio. So, without further ado, let me jump into the video. Let me just have a quick drink first. Okay, so as you can see here, I have a staircase and we have a sphere at the top which represents our basketball or football. It's our rolling object, and then if I play, I'll shut up for a second. So we have our physics object, and if we tap it on the surface, it's nice and quiet. If we hit the surface pretty hard, you can see it makes a different sound, or the volume multiplier is increased the harder you hit the surface. So how do we create that? How do we make it? How would we replicate this? If we right click, go to blueprint class, click on actor, and we're going to call this one our physics object. I'm going to do underscore tutorial, TUT. And then we're going to open it up. Okay, so in here we have nothing, we just got our default scene root, and we're going to add in our component sphere. So we now have our sphere object, our spherical object. This is going to represent our basketball or football, tennis ball, whatever you want to call it. And excuse me, sorry, 1 second. Yeah, tired. Right, so this is going to represent our football, basketball, whatever you want to call it. And in here, we need to do a few things in our details panel before it'll work at all. So we're going to go to simulate physics and enable that, and then click on mass. And we have, take note as well, the default mass is 100 kilos. So everything that we do now in the blueprint in your event graph is reliant on the mass in kilos to be the same. The settings and the values that I input, if your mass kilo is less or more, will also impact the outcome. So if for any reason yours isn't working the same and you have maybe like 50 in here, that's probably why. If you're using exactly the same settings as myself, but yet it's a different mass, then it's going to yield a different result. So the next thing we want to do is scroll down until we see simulation generates hit events. What this means is that on collision, the event dispatcher for event hit component, so when the component hits an object, surface, or a player, or a character, or an NPC, or AI, whatever, then this has to be on in order for the physics system to recognize an impulse, a hit, when it hits a surface. So we're going to click that on. Make sure it says physics actor here. That should have automatically done that when we enabled simulate physics and our mass. When we did that part there, this should have changed automatically to a physics actor. Then what we want to do, we can compile it anyway, but then what we want to do is scroll all the way down, and these are our event dispatchers. And this one here, it'll tell you that it'll only work if you have it checked to on. So we're going to go and click on component hit, and it'll take us to our event graph. If we click here, and we can delete these. I might use that for debugging in a second. Now, first thing I'm going to do is right click on our hit, and we're going to do split. And now it opens up all these other options for us, and the ones that we want is our normal input, our normal impulse, and our hit location. The hit location we're going to use to tell Unreal where we want the sound to come from, because we don't want the sound to play in the player's ears if a ball or a physics object is falling in the distance. it would not only sound strange, but it wouldn't really be realistic, right? So we use the hit location, or the point of impact, as to where we want our sound to project from. So the next thing I'm going to do is get a branch, because we want to add a condition so the sound doesn't just spam. So we're going to hold B, left click to get a branch. Excuse me, 1 second, just have a quick drink. Right, so out of our normal impulse, we're going to get a vector length. Now, if we right click on this and split it, our current setup here is our X, Y, and Z. So let's recombine. If we were to get data from this, let's use an event tick and a print string. So it's really important, if you're new to Unreal, to understand what a print string is and how beneficial it is in helping you solve problems and also to understand what a node is doing. Print strings are seriously underrated. Not only do they give you a full printout of what the node is doing, its calculations, whether it be maths, whether it be a numerical value, but it shows you in real time, especially from an event tick, the exact readout that's coming from this node. So if we get our normal impulse and pop that in there, and then compile this, let's pop that there, let's close that one, and then let's delete that and bring in the physics tutorial one. Let's bring down the size, and if I go in and play, you can see there that we have all of those readouts, right? On the left side, we've got our X, Y, and a Z. So what we can do then is we can get a vector length. Now, a vector length node, try not to make it too complicated for anyone that's trying to follow along. A vector length will convert this into a single value. So currently this is a free vector. It's three lots of different input value or data values, so X, Y, and Z. And then we want to get a vector length, and this then converts this into a single data output. So if we then go into our print string and then play, you can see here now, instead of having our X, Y, and Z data, we've now condensed all that in to a single decimal point with a constant reading. You can see now it doesn't say X, Y, Z, but we've got, try and read that, 1,300 for our rolling impulse. So this is the, I think it's just fallen off the edge. So this is the data reading that we want to connect with in order to reduce the spamming of the audio. What we're going to do with our vector length, now that we have our single data output, we can use a greater than. So we're going to go and hold shift, and you can press the, hold shift and press the little, where the full stop is. These ones, greater than. I always forget everything's name, especially at this time of night. We've got a greater than node, and we're going to connect that into our top input, and then we can copy this. So let's set in here something along the lines of maybe 2500, and then we'll paste it and paste it again. So we want 3 of these nodes. And we can disconnect that there. So let's move that out of the way. Right, so we have our vector length, we have our greater than, and we have 2 more of these. So we've got 3 in total. I'm going to do the same for our branch. So let's go with Control C, Control V, and then we're going to connect this one into here, this one into here, and then this one into here. So these are going to be checking our condition to see whether or not that value is higher than, so if it's 2500 or more, then the condition will be true. If it's less than, so if it's 2500 or less than, so what, 2499 or less, then it won't do anything, that'll be false. So that's going to go into there, that's going to go into there. So we're going to go false into the input of the second, false into the input of the third. Out of our top branch, we're going to get a play sound at location. And then we can double click here, move that across, move that out, and connect these into our reroute node. So we have this here. So I'll hold that there for a second, just so you can kind of follow along a bit easier. And this is what we should have so far. So you should have normal impulse into vector length, from vector length into a greater than node, and then you want to also connect these as well into your, oops, I hate it when I do that, these as well, your A value into your vector length. So all three of these are connected to that top vector length node there. So vector length to A on all three. Right, so click this little drop down arrow. It opens up more options for us on our play sound location node. And then what we want to do is we want to play the sound at the hit location. So the point of impact where the sphere or ball, basketball, whatever you want to call it, is hitting the surface. This is where we want the sound to originate from. So we're going to drag and connect that into our location. Double click. Let's reroute these. Just makes it a little bit easier to follow. Like so. Okay. Right. Now that that's done, we need a sound. So let's get a sound effect. That'll do. So new tutorial. Compile it. So this will work, but there will be some issues which we're going to resolve. So let's just see how it looks so far. Okay. Let's take that out of the print string. So let's do that once more. Okay, so it is working, but we can do better. We can make it a little bit more realistic. Let's make this a little bit better. So let's go and add in a do once. So right click, we can drag out of here and get a do once. And we're going to get a delay. So find out how long your sound file is. So ours is 0.4. So let's do 0.4. And I'm going to connect our completed into our reset. So how this works, now I'm not going to try and teach you how to suck eggs. I'm sure a lot of people understand how a do once works. I think it's quite self-explanatory. But for those that don't understand, that are new to Unreal Engine, how this is working here, we have the code firing. So imagine this is like a person walking, right? So they're starting here at A and they're going to finish over here at B. When the code fires off, you get a little orange line and it travels through, it's going through the branch, and when it gets to the do once node, this locks itself. So it's kind of like a fire escape, right? You can push the bar down. Once it closes, you ain't going back through that door, right? It's a one-way door. This reset is kind of like having someone on the other side of the door able to push the bar down for you to open that door again. So is this kind of like a self-locking gate, but the reset is like your friend waiting for you to finish your cigarette break and then open it for you as you come in. So the code comes through, the do once, we play the sound at location, we have a 0.4 second delay, it loops round, resets this, opens it again, and allows the code to pass through. And then this will do it again and again. So this is like a loop. Passes through, does it once, plays the sound, 0.4 seconds later, reset. Plays sound, 0.4 seconds later, reset. So that's how the do once works with the delay. And that's how you reset them. It can be used for, there's lots of different ways to kind of create that same effect. But this works. So what we want to do now, let's quickly test it. So that's fine, but what we can do is drop that delay down a bit. So let's do 0.25 and then compile. Let's check it now. Okay, so much better, but still the sound is too consistent. The sound is the same volume all the time. And again, that's not realistic. You would have, on varying degrees of intensity of the impact, you'd have a different sound level. So the higher the impact, the higher the volume. The lower the impact, the lower the volume. So this is just a consistent sound. There's a few things we can do to make this better. So let's move this out. Gives us some space. I couldn't speak then for a second. And let's just move that. Okay, so we have pitch and we have volume. So currently it's a flat rate of 1. So our volume multiplier is 1 for every single hit. We also have our pitch, which we can kind of create a bit of randomness to. So we're going to go and get a random float in range. And then we can connect that into our pitch. And then we can set here, we can do a minimum value, let's say 0.8 and a maximum of 1.1. This will give us a little bit more of a random pitch tone. So you can hear that there, the pitch was changing randomly between each hit, which is perfectly fine. And then what we can do as well is we can add in a volume multiplier shift. So we can, the heavier the impact, the louder the volume, the lower the impact, the quieter. So we're going to get a reference to our sphere by dragging that into our event graph. And then we're going to drag out of this and get our get component velocity. And then we want to vector length this, so we can just copy this, paste it, and pop that in there. This is going to convert this from our X, Y, and Z into a single float precision. And then we're going to get a divide. So let's divide this. And we're going to divide it by a bigger number, which just gives us a better result. I'm not that amazing at maths, so don't ask me how that works. I just know the bigger the value, the better result you get. If you have a low value, it's really quiet. The larger the value that you're dividing by, it gives you yields better results for the audio. So we're going to clamp this, and clamping basically means that instead of having a value of, like, let's say 800, 900, 10,000, 3,000, what we do is we clamp, and I believe it's this one. No, it's clamp float. I think I'm after clamp float. There it is. So clamping enables us to set a minimum of 0 and a max of 1, but let's go to 1.5 so we can have a maximum output of 1.5 multiplier for our volume, and we're going to pop that in there. Let's just reroute this. Okay, so we got our sphere reference, get component velocity, return value into vector length, out of our return value into our divide, out of our divide into our clamp, out of our clamp into our volume multiplier. So let's get our print string. Let's move this down here, and let's drag and drop that in there, and then compile it, and we can see what's happening. Let's have a look. Let's try that again. Let's move this to the top of the stairs. So is it on the edge? It is. Okay, so you can see there we have a volume reading on the off side of the screen to the left. So as the momentum of the ball picked up, on the left side of the screen, we could see just here the value was 0.5 and 0.6, and now we've got a value of 0.2. So, show you that again. Okay, now what we can do is I'm going to add a tag to this, and the tag is just so I can pick it up to demonstrate Phsyics, I think it is. This won't work for you unless you've got the code set up, so that if you try and do the same as me and you haven't got it set up, then it won't work. There we go. So you can see if I hit the ball against the wall pretty hard, or the floor, we get a different sound volume. So, I hope this video helps. Again, this is an easier version, so I apologize if it's not what you're looking for, but this is just a simple way to set up some physics audio for your physics objects. This will work with any type of object. You just remember that if the mass of the object is different, a quick message about this. The reason why I put a tag in is because in my first, I may as well explain it just in case it confuses people. In the first person character, I have this code set up here enabling me to pick up objects using a physics handle, and the hit actor has tag. If the actor has a tag of physics, then I can pick it up. That's all it is. It's nothing to do with what we've just created. This was just done separately. I'll leave a link to a video where you can set that up if you want to follow it, so that's fine. But the point being for this, if for example you want to have a heavier object, just remember that the value in here is what the normal impulse is affected by. So the lower this is, the lower this would be. The higher this is, the higher this would be. Because a 100 kilo object dropping on your toe, you're not going to have much of a toe left. A 1 kilo object is going to hurt, right? The normal impulse is that value. So the heavier the object, the higher this value will be. So the higher this value here would have to be to compensate for that. The lower this value on your mass, on this, the lower this would be. So let's say I set this to 1, then this would have to be like 200. If I set this to like 50, then this would have to be like maybe 1,000 or something along those lines. But that's something that you can use the print string for in order to determine the vector length, to then determine the amount that you'd need to put into these. So if anyone's confused, please let me know, but I tried to explain it the best I could. But yeah, thanks very much for watching. If you like the video, please like it. It helps with the YouTube algorithm. Please hit that subscribe button. I notice there's a lot of people that do watch the video and hit the like button, but they don't subscribe. And subscribing is how it helps the channel get noticed more. And it's a free way to help me for helping you. So I appreciate everybody taking your time to watch it. Thanks very much for watching, and I'll see you all in the next one. Bye bye for now.